In today's note, we are going to be looking at a summary of all the quadratic expressions that we've looked at and basically all the different forms. We're going to be going over what each form tells us, and in the end we're going to look at how can we go from one form to another, because all of them give us different pieces of information, so it's helpful to be able to convert between our forms. That way we can find all the information possible. So the first thing we're going to look at is our vertex form. Our vertex form, remember, is a quadratic that's in the form y equals a times x minus h squared plus k. The three variables that we should have filled in that give us some information are the a value, which tells us the direction of the opening as well as the step pattern, the h value, and the opposite of this number is the x value of the vertex. Right, so if we see negative, it's actually positive. If we see positive, it's actually negative. This is also the axis of symmetry. And finally, the k value is the y value of the vertex, and this is also known as the optimal max or min value. So again, those are the three things that we are looking for in this equation, and those are the three pieces of information that the vertex form gives us. If you need to review vertex form more thoroughly, please go back and look at that lesson. One thing to note though, the vertex form can be changed into standard form by expanding. So we looked at that in the last lesson. By expanding this form, we can change our vertex form to standard form, and standard form does give us some other additional pieces of information. So we're just going to review vertex form right now, and just looking at the first question, given the parabola and equation below, determine the given information. Right, so we see the equation, we see the parabola, they are the same ones, just two different representations of it. We want to know the vertex, the optimal value, the axis of symmetry, and the step pattern. So from the equation, the a value we can see is 2, h is positive 6, or the opposite of what we see here, and k is minus 4. We can see on our graph our vertex is right there, and our vertex has the point 6, negative 4. We could have also gotten that from our h and k value, because the vertex form tells us that the vertex is hk. The optimal value is the y value of the vertex, or the k value, which in this case is negative 4. The axis of symmetry is that imaginary line that cuts our parabola in half. So in this case, it's going to be in the form, it's always in the form x equals, and in this case it's x equals 6, or you could say the h value of the vertex, or the x value of the vertex, or h. And then finally, our step pattern, because our a value is 2, remember our step pattern is 1a, 3a, 5a. So our step pattern in this case, 1 times 2 is 2, 3 times 2 is 6, and 5 times 2 is 10. So by using our a value and this general form for our step pattern, we should get that our step pattern is 2, 6, 10. And again, we can also see that from our quadratic or our parabola. As we move over 1, we go up to the next point. Over 1, up 6 to our next point, and so on. The second question is something similar we've done before. Determine the equation of a quadratic given our vertex of 1 and 2, and it goes through the point 8 and 16. And we want to sketch this parabola, so we just want to draw generally what it looks like. Again, remember that our vertex tells us our h value and our k value. So in this case, our h is 1 and our k is 2. Our point tells us an x and a y, so x is 8 and y is 16. And using all of that, we can plug all those values into our vertex form equation, y equals a, x minus h squared plus k, and help us find our a value. Because the a value is the only other one we need, but we don't have it. It's not given to us. So as long as we can plug all the other, or fill in all the other variables, we can use algebra to solve for that a value. So in this case, we have 16 equals a, x is 8 minus h, which is 1, squared plus 2. I'm going to solve my bracket first. So 8 minus 1 is 7, squared plus 2. 16 equals a times 49. This is 7 squared, or 7 times 7 is 49, plus 2. Could also, if I wanted to, rewrite this as just 49a, or a times 49, same thing. So 49a plus 2 equals 16. I want to get rid of the 2 on the one side to get a by itself, so I'm going to minus 2. Minus 2 from the other side. One side cancels out, so we have 14 equals 49a. Now to get a by itself, I have to divide both sides by 49. One side will cancel out, and we have, bring this up over here, we have 14 over 49 equals a, and we can reduce this fraction to 1 over 7, which equals a. Or not, sorry, not 1 over 7, 2 over 7. Because both numbers can be divided by 7. 14 divided by 7 is 2. 49 divided by 7 is 7. So now I have my a value, so I can rewrite my equation. Y equals, I know my a is 2 over 7, then x minus 1 squared plus 2, and this is my equation, or this is the equation of this quadratic. If I want to graph this, or just roughly sketch this, just roughly draw my grid, I know the vertex is 1 and 2, so let's just say 1 and 2. So there's my vertex. I know that at 8, so let's say it's all the way down here, 8 and 16, there's a point. So if I roughly graph it like that, I know it opens up because of the a value. So that is roughly what my quadratic looks like. Again, just a sketch, so it doesn't need to be anything super accurate, especially given the information we have. Moving on to our next form. Our next form is factored form. And factored form is is a quadratic that's written as y equals a times x minus r bracket times x minus s bracket. So this again tells us some information about our quadratic that helps us understand what it looks like and how it appears on a graph. The a value, again, is the same thing. It tells us the direction of the opening as well as the step pattern. This a value represents the same thing as it did in the vertex form, and it's also located in roughly the same spot. It's that first number that we should see, or that first multiple or multiplier. The two numbers in the brackets, or more specifically the opposite of these numbers, are the zeros of the parabola, or in this case the parabola, or not also zeros, x-intercepts, roots. So basically in this case, the parabola would have zeros of r and s, or specifically the point r0 and s0, because again, if it's the x-intercepts, they cross the x-axis. Again, remember the key thing is when we're looking inside brackets with quadratics and we're trying to get information from it, we're taking the opposite number. So in this case, if it appears as negative, it's actually positive. If it appears as positive, it's actually negative. Some things about the factored form is that the quadratic in factored form can be converted to standard form by expanding using the FOIL or box method. So same as vertex form, we can convert the factored form into standard form by expanding or basically multiplying all of our terms. The quadratic in factored form can also be converted to vertex form by determining the vertex and using the a value given. So if we can find the vertex, which we've learned about in a previous lesson, we can plug that into vertex form, use the same a value, and we would have our equation in vertex form. So the factored form actually lets us convert to either of the other two forms quite easily. So what we want to do in the next example is determine the x-intercepts, step pattern, and vertex for this equation of a quadratic, and we want to sketch the parabola. So in this case, my x-intercepts are going to be the opposite of these two numbers. So my x-intercepts in this case are going to be 2 and -4, because it's the opposite of what we see. The step pattern, again, follows that 1a, 3a, 5a pattern that we've seen in all the other forms. I look for the number in front out here. I don't see anything, so I assume there has to be an invisible 1. That means my step pattern is 1 times 1, which is 1, 3 times 1, which is 3, and 5 times 1, which is 5. To find my vertex, I need to do a few calculations. Remember, to find the x value of the vertex, that's going to be somewhere, that's going to be in the middle of these 2 points. If I were to plot these 2 points at 2 and -4, I could find the middle of these 2 points, which would actually be on -1. So I know my vertex has to be somewhere along that line, or along that axis of symmetry, because it needs to be in the middle. Mathematically, if we want to figure out that middle value, we add our 2 roots, so 2 plus -4, and divide by 2, or basically find the halfway value, or middle value. So we get -2 over 2, which equals -1, which is what we've seen with using our kind of grid to help us find the middle. To find the y value of the vertex, I'm going to use my equation, and instead of x, I'm going to write in the value that I found, -1, and I'm just going to solve. So all I did was I put negative in for x, and I'm going to solve. So y equals, we have -2 minus, or -1 minus 2, so -3, times -1 plus 4, so +3. So y equals -9. That means that my vertex is the point -1, -9. So I can fill that blank in. And I can plot that on my graph, -1, -9, right down here. If I want, I can also use my step pattern to find other points on this graph. So over 1, up 1. Those are another points, over 1, up 3. And if I go over 1, up 5, I get to my x-intercepts. So I've kind of graphed everything that I can right now. So let's connect all these points. And there is my parabola. Secondly, if I want to write this above equation or above quadratic in vertex form, I can do that as well. Again, reviewing from just what we talked about, vertex form, y equals a, x minus h squared plus k. I know my h and k value now from my vertex that I found, and I know my a value because it's the same as the y, or my factored form. So y equals a is 1 times x minus -1, so x plus 1 squared minus 9. So that is my vertex form equation. Let me just move this below. Or actually, move it off to the side. So again, if we're given factored form, we can figure out our vertex form equation by easily figuring out our vertex. The last thing we want to do is determine the equation of a quadratic in factored form given the x-intercepts and going through a specific point. So remember, the x-intercepts tell us our r and our s value. Oops. Let me go back here. They tell us our r and our s value. In this case, the r value, again, remember, opposite of what we see, so we see, or not opposite, we see, sorry, r equals -4 and s equals 2. So the two x-intercepts are the two values of our x-intercepts. The point tells us an x value of -1 and a y value of 3. Similar to what we did with vertex form, I can take these four values, plug them into our equation for factored form. So y equals ax minus r times x minus s. And once I plug everything in, I should be able to solve for a. So in this case, y equals 3, a we don't know, x minus r, so -1 minus -4, -1 minus 2, and when we simplify this, a 3 equals a, or -1 plus 4 is 3 times -3. So we have 3 equals a times -9. To get rid of the -9, I'm going to divide both sides by -9. One side will cancel out. And I'm left with 3 over -9 equals a. Or I can reduce this to -1 over 3 equals a. Now that I have my a value, I can rewrite my equation. Y equals -1 over 3. Then I have x minus -4, or x plus 4. And then x minus 2. And there is my factored form of the equation. Our final form that we're going to look at is standard form. And standard form only gives us two pieces of information. It tells, or sorry, I guess starting off, the standard form is in the form y equals ax squared plus bx plus c. The a value, again, tells us the same thing as what we've looked at in the past. It tells us the direction of the opening as well as the step pattern. The only other piece of information the standard form gives us is our c value, which is the y-intercept, or basically the point 0c, where the parabola crosses the x-axis. Our quadratic in standard form can be converted back to standard, or back to factored form. So we can go from standard to factored by factoring. And we're going to look at factoring in the next unit, so you don't need to worry about it right now, but just understand that if we wanted to, we can convert standard form to factored form. And if we wanted to from there, we could go from factored to vertex and so on. So we talked about in the last two forms that in order to get to standard form, we just have to expand any of our two other forms, and that will get us to standard form. So that's what we're going to do right now. Again, you can use FOIL or box method. Again, it's up to you, whichever one you prefer. I'll do one of each so that you can at least see the two examples. And we'll see two examples in vertex and two examples in factored form. So A and B are in our vertex form. We should be starting to recognize what vertex form looks like. But I'll do the first one in using the FOIL method. So if I want to rewrite this, x plus 4, let me write it a little bigger, x plus 4 squared is basically just saying x plus 4 times x plus 4. The plus 3 stays on at the end. I'm going to worry about that after. So FOIL method, first times first, first times, or first and last. No, sorry, first outside, inside, last. Getting my acronyms confused. So this basically works out to x times x, which is x squared, x times 4, which is 4x, 4 times x, which is 4x, and 4 times 4, which is 16. And I'm going to bring the plus 3 down because I haven't multiplied that through, so it just gets added on at the end. I should be able to recognize again I have two middle terms that are the same, as well because of the plus 3 at the end I have two constants that are the same. So by combining these, I should get x squared plus 8x plus 19. So we can see there, now this is in standard form. So we went from vertex form, we expanded, collected our like terms, and we got to standard form. I'm going to do the same thing with b. However, we do have to do one thing first. Right? If I wanted to rewrite this, negative 2 times x minus 2, because of the squared, that means the bracket is multiplied by itself. But I should see that I have three things that are being multiplied here. The negative 2, the x minus 2, the x minus 2 again. Right? So, in order to use the box method, which is what I'm going to do this one in, I have to simplify some things first. And I do that by multiplying the negative 2 into the first bracket. It's only the first bracket because it's when we think about multiplying numbers, we multiply the first two, then take that answer and multiply it by the second one. So in this case we get negative 2x plus 4, or negative 2 times x is negative 2x, negative 2 times negative 2 is positive 4. Then x minus 2 is my second bracket, and I'll still carry in the minus 6. Now we just have two brackets, so I can use the box method now. Negative 2x and 4 is in one bracket, x and minus 2 is in another bracket. I'm going to worry about the minus 6 after. Now I'm going to multiply my corresponding columns and rows. So negative 2x squared, 4x, 4x, negative 8. Again, remember we should see that if we've done it correctly, our two diagonals are the ones that we have to combine or simplify. Excuse me. So if I rewrite this, next step, simplified, I have negative 2x squared plus 8x minus 8. I'm going to bring the negative 6 down, because that's just going to get added in. And now I should see that I only have two like terms in this step because I've already combined the other ones. So negative 2x squared plus 8x minus 14 is my equation in standard form. So a little bit longer because we had an extra step, but again, the idea is still the same. We still get to standard form in the end. For C we have factored form. Again, I'm going to use FOIL method first, and then we'll use box method. With the FOIL method, because we have three things that are multiplied, we don't see anything in front, but we have to assume, because of the negative, that there's an invisible 1. So that means I need to multiply that first number through first. So I'm going to get negative x minus 5. The x plus 9 stays the same. And now I can use my FOIL method. So first, outside, inside, last. So I get negative x times x, so negative x squared. Negative x times 9, so negative 9x. Negative 5 times x, or negative 5x, negative 5 times 9, or negative 45. I should see that my two middle terms I can add together. Again, same thing, I've done this correctly, so my two middle terms should be my like terms, or my only like terms. So I get x squared minus 14x minus 45, and now I have my equation in standard form. Lastly, again, same idea. I have an equation in factored form and I want to write it or expand it to go into standard form. I'm going to use box method for this one. Before I do that though, I see that I have three things multiplied, not just two brackets. So I have to expand this first, or multiply the 3 through to the first bracket. So we have 3x minus 6. Then the x plus 6 just gets carried down. I can now put those two brackets onto the box. So 3x minus 6, x plus 6. Multiply my corresponding columns and rows. So 3x squared minus 6x, 18x, and negative 36. I see that my two diagonal boxes are my like terms. So when I simplify this, 3x squared minus 12x minus 36 is my equation in standard form. So basically I just added up these two diagonals to get the negative 12x, and I wrote everything else as is because there are no other like terms to combine. So regardless of which form we're given, we can always convert to standard form just by expanding or multiplying and then simplifying and collecting any of our like terms. So here is just kind of an overview of how we can go from one to another. So if we have vertex form, we can go to standard form by expanding, or so basically using the FOIL or the box method. If we have factored form we can work into vertex form by determining the vertex using the steps of finding the x value or the middle value, then subbing in and solving y, which we have just done, and we use the same a value. To go from factored to standard, we just expand. So similar to what we just did, we expand by using FOIL or box method. So factored form is actually quite versatile because from that one form alone, we can go to either vertex or standard form. And then finally, standard form, we can only convert going back to factored form by using factoring, which we are going to learn or review, I guess I should say, in the next lesson. You should have learned a little bit of it in grade 10, but going back, we can go back to factored form through factoring, and then from factoring, if we want to, we can go back to vertex form. So this is just kind of an overview of all the three forms and just how we can convert from one to another. And we just looked at some question specific or form specific questions that you may come across in the future.